When it comes to correcting weld imperfections, using carbide burrs is one of the most effective and precise methods available. Whether you are a professional welder or a hobbyist, mastering the proper use of carbide burrs will significantly improve the appearance, integrity, and longevity of your welded joints. Let's walk through everything you need to know to use carbide burrs effectively for weld imperfection correction, from understanding the tools, to detailed step-by-step techniques, to essential safety and maintenance tips. First, it's important to understand what carbide burrs are and why they're so widely used in weld cleanup. Carbide burrs are rotary cutting tools made from tough tungsten carbide, a material known for its extreme hardness and durability. These burrs are designed to be attached to high-speed rotary tools, such as die grinders, Dremels, or pneumatic grinders, making them ideal for grinding, shaping, and removing material. The variety of shapes and cutting patterns available for carbide burrs allows you to tackle different types of weld imperfections with precision. There are several main types of carbide burrs commonly used in weld correction. Cylindrical burrs are excellent for working on flat surfaces or for removing excess weld material and spatter. Ball burrs are perfect for smoothing out rounded or concave areas, and also for cleaning up uneven beads. Tree-shaped burrs are useful for getting into intricate or tight spaces, which are often present in more complex welds. Flame or oval burrs are best for contouring and smoothing curved weld surfaces. In addition to shape, burrs come in single-cut and double-cut varieties. Double-cut burrs, with their cross-cut pattern, provide smoother finishes and greater control, making them ideal for final cleanup and blending. Single-cut burrs, on the other hand, are more aggressive and are best reserved for heavy material removal, such as grinding down large weld beads or thick slag. Before you begin, gather all necessary tools and safety equipment. You'll need a high-speed rotary tool that matches the shank size of your chosen burr. Most commonly, burrs are available with 1/4 inch or 1/8 inch shanks, so ensure your grinder or Dremel collet is compatible. Select the right carbide burrs for the task at hand, and have cleaning tools such as a wire brush and compressed air on hand for both pre- and post-grinding cleanup. Safety should never be an afterthought. Wear safety glasses or a face shield to protect your eyes from flying debris, heavy-duty gloves to prevent cuts or burns, a dust mask or respirator to avoid inhaling metal particles, and hearing protection if you're using a loud pneumatic grinder. Long sleeves and protective clothing will help shield your skin from sparks and debris. Preparation is key to achieving professional results. Start by carefully inspecting your weld. Look for common imperfections such as spatter, uneven beads, slag, or porosity. Clean the weld area thoroughly using a wire brush or solvent to remove any loose slag, dirt, or debris. If you're working with stick or flux cord welds, use a slag hammer to chip off heavy slag before proceeding with grinding. Securing your workpiece is essential for both safety and precision. Clamp it firmly to a stable surface, and, if necessary, use a marker to highlight specific problem areas for targeted grinding. Choosing the correct burr and tool settings is crucial for effective weld correction. Match the burr shape to the imperfection: cylindrical for flat surfaces, ball for rounded areas, tree for intricate spaces, and so on. Select a double-cut burr for finishing and blending, and a single-cut burr for more aggressive material removal. Always ensure the burr's shank fits securely in your tool's collet. Adjust the speed of your rotary tool based on both the size of the burr and the type of material you're working with. For example, when working with steel or stainless steel, operate smaller burrs at 10,000–20,000 RPM and larger burrs at 6,000–10,000 RPM. For softer metals like aluminum, use lower speeds, around 5,000–10,000 RPM, to prevent clogging. Always refer to the manufacturer's recommendations for optimal RPM ranges. When you're ready to start grinding, hold the rotary tool at a 15 to 30 degree angle to the weld surface and begin with light, consistent pressure. Avoid forcing the tool, as excessive pressure can cause gouging or overheating. Work in stages. If you're removing excess weld material or spatter, start with a single-cut cylindrical burr and move in a controlled linear motion along the weld bead. For smoothing out uneven beads, switch to a double-cut burr and blend the weld into the base material for a uniform, seamless appearance. Heavy slag should be removed first with a single-cut burr, then finished with a double-cut burr for a smoother result. Use short, controlled motions and move the burr steadily across the weld to avoid creating divots or uneven surfaces. Take extra care in intricate areas by using smaller burrs and slower, more deliberate movements. It's important to avoid overheating the workpiece. Periodically lift the burr off the surface to allow both the tool and material to cool, especially when working with stainless steel or thinner materials, which can warp or discolor if overheated. Check your progress frequently. Stop often to inspect the weld and ensure you're achieving the desired level of smoothness and uniformity. This helps prevent overgrinding, which can weaken the weld or create thin spots. Once the grinding is done, thoroughly clean the weld area using compressed air or a wire brush to remove all metal shavings and dust. Inspect the surface for any remaining imperfections and touch up as needed. For a polished finish, you can follow up with a finer grit flap disc, sanding pad, or polishing wheel. If the weld will be exposed to the elements or requires painting, apply the appropriate primer or protective coating after cleaning. Proper maintenance of your carbide burrs will extend their life and maintain cutting efficiency. After use, clean the burr with a wire brush or compressed air, especially if you've been working with softer metals like aluminum, which tend to clog the flutes. Inspect the burr regularly for wear or damage. Replace it if the cutting edges are dull or chipped. Store your burrs in a protective case to prevent damage when not in use. For the best results, practice on scrap material to get a feel for the cutting action and speed of your tool. Always match the burr to the hardness of the material you're working on. Use proper ventilation, and avoid excessive force. Let the burr do the work. Steer clear of common mistakes like using the wrong burr shape, or cut for your application, overgrinding, operating at incorrect speeds, or neglecting safety gear. Above all, remember that safety comes first. Ensure your rotary tool is in good working order. Keep your hands and clothing clear of the spinning burr, and always maintain a stable working position. By following these steps, you will be able to correct weld imperfections with precision, efficiency, and confidence, resulting in strong, smooth, and visually appealing welds every time.